Greetings, students. We come now to our third programming language called MATLAB. This is a high-level language for scientific and engineering computing. The name MATLAB is Matrix Laboratory. You will realize that we'll be dealing with a lot of matrices in MATLAB. It has got interfaces for other languages that we have already learned, like C, C++, Java, etc., including Microsoft Excel. It is very good at curve fitting, classification, and it has got functionalities for signal analysis, control systems tuning. One of the good things about MATLAB is graphics for visualization, as you shall see as we create custom plots. I hope by now you have installed your MATLAB and you are ready to get started with using MATLAB. When you start your MATLAB, that is the default layout you see on the screen. The area in the center of the screen, the white area, which is a command window, is the one where we type in our commands. And in MATLAB, you can type in your commands as you move on with your work. Like you could have there A equals 3, B equals 4. Then you can compute your C being A plus B. As you press enter after every command, it executes immediately and shows you the answer. You can try that. On the left of the screen, you'll be able to keep track of the history of your commands as you type them. They'll all be documented on the left. You may have different versions of MATLAB, but the concepts and the look and feel will be very similar with minor changes from one version to the other. Take note of the important aspects of the default layout window. The current folder, which allows you to access your files, the command window, as we have already mentioned, where you do all your commands and get your output, and the workspace where you explore data that you create and or import from files. It can come out in the form of matrices, single variables, constants, etc., or arrays. As you work in MATLAB, you'll be issuing commands on the fly, and you'll be calling some functions there. Once you assign your variables and call some of these functions, the output is immediate. Let's try this. You type in A equals 1. You should have a return value from the command window showing the output of A equals 1. You could create a few more variables and a few more expressions and get the feel of MATLAB. Like I mentioned, MATLAB is all about matrices. It easily handles your matrices. That's why it is called MATLAB, for Matrix Laboratory. To create a matrix that has multiple rows, separate the rows with semicolons. This is how you create a simple matrix where you can say a 3 by 3 matrix as shown on the screen there. You use your square brackets to show that it's a matrix, and you separate each with a semicolon. The output will present your data in the form of a matrix. May you go ahead on your command window and create matrix A. You could also create other matrices which are standard as quick as you can, like the zeros matrix. 5 rows, 1 column. It gives you a column vector. You can go ahead and try that. Let's go on to the matrix and array operations. MATLAB will allow you to process all of the values in a matrix using a single arithmetic operator or function. We defined already our matrix A. We could have A plus 10 as a new matrix where each of the elements of the array are added a value of 10, and we get the answer instantly across all the indices of that matrix. We could also have an operation where we would like to find the sign of A, and MATLAB will compute that based on the array A that we created earlier on. I will use the word matrix and array interchangeably. Matrix operations, like the transpose of a matrix, are done more like the way we used to write them down in pen, where a transpose we just use a single chord. MATLAB knows how to compile that and interpret it as a transpose of a matrix. Inner products and some of the standard matrix multiplication can be performed using the asterisk or the star, which denotes multiplication. Like in this case, we want to create a product of A times its inverse, which gives us an identity matrix. May you go ahead and carry out that example on your matrix A. We also can use the format command, that is to reduce or to increase the number of decimal places on our data set, depending on the data type that we use, as in the example given. Go ahead and try that example where you're going to format your matrix to a particular number of decimal places. As I mentioned earlier on, graphs and visualization is one of MATLAB's strongholds. You are expected in this course to know how to draw your 2D plots and your 3D plots. So we shall go ahead and focus on those two aspects. To create 2D plots, we use the plot function. For example, you can be asked to create the plot of the sine wave from 0 to pi. Let's copy the syntax where the first line there, x is equals to 0 colon pi over 100 colon 2 pi. What it's basically saying is, let's create possible values of x starting from 0 to 2 pi by stepping by a pi over 100. So we'll have several values of x that we're going to then compute f of x against. Once we've got the pair value of x and f of x, then we're able now to plot our f of x. If you wish to see the values, you do not specify the semicolon at the end of your statement. But if you wish, you can suppress those output by using the semicolon. Once you've got your possible space of x values, you can then compute your y, the dependent variable, using your formula. In this case, we're working with sine x. So now you will have all possible values of y and all possible values of x within the space 0 to 2 pi. You can now plot your x, y using the plot keyword, which is a reserved word in MATLAB that will plot the sine wave for you. Go ahead and try that. It's important that your graphical visualizations are properly labeled. This is how you label your graphs in MATLAB, where you've got X label keyword to give us the label for the X column or X dataset, the Y label to give us for the vertical axis. Obviously, we need a title, and we use the keyword title to specify the title for the graph that we are working on. You could also do some cosmetics to change the plot line to red to dotted by using the inbuilt command as shown in bold on the screen. You have got a task there to create a graph of y is equal to x squared for x between 0 and 100. You increment by 10. You also have to do the same for cos x for x between -2 and 2 pi, incrementing by pi over 100. Trying these examples will help you appreciate graphical presentation of your solutions in MATLAB. Let us move on to 3D plots. 3D plots typically display a surface defined by a function in two variables, that is, z is equal to f of x and y. To evaluate z, first create a set of possible values for x and y over the domain. And then we use a special function inbuilt in MATLAB called meshgrid. Just like we did for the 2D plots, we need the possible values of x and y, and then we evaluate our f of z. You will then get such kind of graphs, which are surface and or the steps involved in creating 3D graphs. You create the possible values. In this case, because we've got two independent variables, x and y, we use the syntax shown on the screen as is. Like I mentioned before, syntax is supposed to be obeyed as is. So you create the possible values of x and y between -3 and 3. Then you apply the function to the grid to get possible values of z. Once you've evaluated z, then now you've got three sets of values. Values for x, values for y, and values for f of x and y. You are then able to plot the 3D diagram graph using the mesh or the surface command. You have an example to carry out there to plot a 3D graph of z is equal to x e to the power x squared minus y squared. So the steps are outlined there. May you carry out this example and prepare for our live class discussions over the weekend. We also have got a task on our exercises in our Google Classroom where you need to try out question 9. All MATLAB functions have a supporting documentation that includes examples, describes how the function works, its inputs, how you call it, and the parameters. It will be difficult to master and know all the functions at once, so you need to be familiar with the use of the help file in MATLAB. This will help you understand some of the commonly used functions, how you're going to use them. To get access to the help file, you open the function documentation using the doc command. For example, for the min function, we are looking for the documentation for the min, we'll say doc min. You then need to be able to utilize the help file to get used to some of the more frequently used functions in any data analysis. In our next lesson, we'll look at doing functions in MATLAB. Thank you for joining this session. Let's meet once again for the next part on our MATLAB course, which is doing functions. Thank you for joining.